we go. Here's an example. Now I want you to look at this for a second. How would I type this in my calculator? It's a good question. How would I type y squared in my calculator? What would I do?
Square root of 4x.
Oh, you'd have to take the square root of both sides, and you get y equals plus or minus that's how you would type it in. So if you wanted to see this picture, you're going to do two different equations. Good question. You're going to hit second square root. Yeah. 4x minus 12. And the other one is negative square root 4x minus 12. By the way, based on your last test, is this going to be a function? No, because it's not unique. There's two x values for this one y. So when we graph it, you'll see the picture. And there it is. I have it on the TV. Does that appear to have symmetry to the x-axis?
Yes.
Yeah, it does. You can look at your table. I'm not going to do that right now because that's not what I'm testing you on. How do you, let's go back to the original problem. So algebraically, on your test, you're going to have to prove whether or not this has symmetry to the x-axis. What do?
Plug in negative y for y.
You replace, every time you see a y, you're going to put in its place negative y. So here we go. We've got, here's a y. It's the only place I see a y value. Now I'm going to do my algebraic magic. What happens here? This is going to stay as a positive. And do we get the same equation? Yeah.
So,
Now can you give me an example of when it would not work out?
Odd.
If that were odd. If this were odd. You would see that you can't get y cubed back to, and if you multiplied everything by negative 1, it still won't work. So this one did work. And you're good. Now, this is the one that Jordan was asking. Yeah.
So the square value, if it were odd, but the number itself were even, so
Say it again. If
like if that were like 3,
if it were y cubed,
yeah. Like even though like that's odd, but it's even.
like that,
Yeah.
that's not going to work. Because when you put a negative negative y here,
Oh, so if it were,
this is going to stay like that. Now what you would do is multiply everything by negative 1, and you're still, it's a different equation. It's different. Okay? Next. The last symmetry you're going to do is the origin. You guys know where the origin is?
Yeah.
7.
It's right
7,
here.
4, right?
Oh, I said 7 times.
Here's the origin. Here's a picture. How you know if a graph has symmetry to the origin? If you picked a point on the graph and you drew a line through the origin, straight through to hit another point, these two should be equal in size. They better be. And if this ordered pair is, let's say, 3, 5, this ordered pair would be -3, -5. What did I do?
Change signs of both y and x.
You changed both of them.
Yeah, mine have gone.
I know. So, that picture that I had, I was showing you here. This point, Jordan, you asked me this one right here. Does this one have symmetry? Does this have symmetry to the x-axis? Does it have symmetry to the y-axis? No. Does it have symmetry to the origin? No. But it does have symmetry.
What's the
It has symmetry to this point.
What?
See this point right here? If you took it, this has symmetry. If you drew a line through it right here, you would see these two are the same. This graph has symmetry to the line 0 to the point 0, -4. But you can't do that test because I'm testing for origin symmetry. The origin symmetry test is you're going to take your x value and your y value and you're going to change both of their signs. So let's do it on this example right here. Now you could graph this on a calculator. So what would you get? I would put in parentheses x cubed divided by 10 and then minus x. I'm going to graph it. Now, what I would want to do is I would look at my table, and you want to make sure, look at this point, this is -3.3, then you'd want +3, -0.3. See this? -2, 1.2, you'd want +2, -1.2. So all of the ordered pairs are opposite. Now look at the oddball point, that's it right there, 0, 0. That means it has symmetry to the origin. Algebraically, what would you do?
Switch the Y's.
You're going to put x and y. Whoops. You're going to replace x for -x and y for -y. So let's do that. So here's a y. We're going to write -y. Here's an x. See what I did? There's a negative here. That stays. I'm going to make this x -x. Now obviously the way it is right now, we don't know. We have to clean this up, simplify it. This is going to stay the same. What's a negative number multiplied 3 times? Is it going to be negative or positive? And what about these two? What's going to happen? So I simplified my problem. Does it look the same as that? No. Now this is where you're going to want to be creative. Could I do something to this problem and try to get it like that one? If I multiplied the whole thing by -1, what would happen to this problem?
And go back to original.
And now we are identical to that. So yes, it is symmetrical to the origin. Now this one has a special name. This is also called an odd function. So, 2 of the 3 have special names. If a graph has symmetry to the y-axis, it's called an even function. And if it has symmetry to the origin, it's an odd function. A lot of memorizing here. So I could ask you, is this equation, is it an odd function? Then you would have to, in your mind, say, well, what is an odd function? An odd function is when an equation has symmetry to the origin, and that's when you replace x for -x and y for -y. So you'd have to do that. I could say, does this have symmetry to the y-axis? I could say, is this an even function? Those two mean the same thing. Okay? Are you with me? Is good? All right, next. Let's do some. If you just look at the back page, it's everything that I already said. All that this is a little chart of a summary of what we just did. In the one column, it asks you symmetry to what? The x-axis, the y-axis, the x-axis, or the origin. to coordinate test it, what you do for each case, and algebraically what you do. So this is just a summary. And I already explained to you what even and odd means. Even means it's symmetry to the y-axis. Odd is symmetry to the origin. What's an easy way to remember the odd and odd one? They both start with O. That's how I remembered it. They both start with O. Okay? Then you're just gonna have to remember the even one is the y-axis. Maybe what you could think of for how come there's no name, anyone know why there's no special name for if it has symmetry to the x-axis?
Not a function.
Because it's not a function. Look at these words. Even function, odd function. Function means if you drew a line through it vertically, it passes the vertical line test. But for an even, if you had a picture, something like this that we just did, this one has symmetry to the x-axis, but it's not a function. So we can't call it another name. We can't use that word function with those ones. Does that make sense?
Yeah.
Hopefully it does. Okay, Flip, this is your homework.
Do we have to graph
My
them?
desk has to be sure if it's not really.
If it says graph, you can use your graphing calculator.
Okay.
You wanna do that?
So, in questions, it says 1 through 6, but I only put up to 4. Oh my God.
You need to put that on your stack of papers right there.
I know.
Yeah.
All right, let's start working here. So for this first one, what should you do?
Put it in your calculator.
And what do you get?
Yes.
Guess what? Read the question. I want you guys to read the question. What are they asking you for?
The y-axis.
They're asking you for 3 things, you guys. So when you say yes, guess what?
Symmetric.
Guess
On the
what?
y-axis.
Yes, y-axis? How about x-axis?
No. It's y-axis.
No. How about the origin?
No.
No.
Yeah.
So it's several answers. So for the x-axis, the y-axis, and the origin, you would say no, yes, no. You guys have to answer the question.
If so.
You guys know how to solve this equation? If you were to use your graphing calculator, what would you do? What if this said, you remember how to solve this for x? What did you do? You'd square root both sides, right? See if you know what to do here. Right? And then what would you do? Right? Okay, so now look at this one. What should you do? Now if you want to, guys, it might help you to reverse it.